Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Sara Vero about being fieldwork ready. Fieldwork is an important counterpart to lab work, where hypotheses can be tested at larger and more variable scales. However, it does pose its own set of challenges to success, including risks and hazards you might not encounter in the lab. This episode, we'll talk with Sara about why fieldwork is important, questions you need to consider before starting, and how to stay safe out in the field. We'll talk more about that in a minute, but before we dive in, we want to thank our sponsors, starting with Gasmet Technologies, the maker of the GT5000 Terra, the smallest portable FTIR multi-gas analyzer for greenhouse gas and environmental research. Measure carbon dioxide, carbon monoxide, methane, nitrous oxide, nitric oxide, nitrogen dioxide, ammonia, and water vapor in real time simultaneously from static or automated chambers. Visit www.gasmet.com, that's Gasmet spelled Gasmet, or email sales@gasmet.com for more information. Our second sponsor is Meter Group. Meter specializes in robust soil and moisture sensing, innovative weather monitoring, cloud data logging, advanced data visualization software, and more. Their well-published scientific instrumentation is used worldwide in universities, research and testing labs, government agencies, agriculture, and industrial applications. Find world-class webinars about the science behind environmental measurements at metergroup.com/fieldlabearth. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Sara Vero with us. Sara is a lecturer in agriculture and environmental science at Waterford Institute of Technology in Ireland. Her research focuses on soil physics, nutrient management, and water quality. She conducted her PhD on nitrate time lag in the unsaturated zone and then did a postdoc at Kansas State University. Her new book, Fieldwork Ready, provides insights into the skills which make agricultural and environmental researchers successful in field research. Hi, Sara. Welcome to the show. How are you doing today?
Good, Abby. Thank you so much for having me.
Oh, we are so happy to have you. For people who aren't aware, Sara has been with us as a friend and fan of the show basically since our start. So it's such a pleasure to have you here. Thank you for being such a great human. So to get us started here, we are talking about your book today. Congratulations on that. So can you just give us some insight into why you wanted to write Fieldwork Ready and kind of maybe the gap you were hoping to fill with this book?
Sure, absolutely. I suppose, to my mind, field research really is the foundation or the backbone of agricultural and environmental science, because essentially we're trying to study, to better understand and to better manage the natural environment. And that means the environment outside of our front door or outside the laboratory for that matter. And for that reason, we really have to emphasize field research and make huge efforts to support it and to further it. However, there are some challenges associated with field research that I don't think are always best prepared for. Certainly, I haven't always been best prepared for them, and they're not usually the technical challenges because it's relatively straightforward to get training in specific devices or specific measurements. But often you see research projects struggle because of logistical challenges, and these are kind of the soft skills. And we more and more pay attention to the soft skills in other aspects of our research careers, such as communications or presentation. But I'd never really come across any training in, I suppose, the logistical aspects of field research. And I kind of felt there was a gap there and a very steep learning curve, particularly for students or early career researchers. And that's what I wanted to address with Fieldwork Ready.
Yeah, and I think you did an exceptional job of what I have read in your book so far. And one of the things that I really appreciated about this book, besides the fact that it's very accessible to read. It's not very like technical or jargony, which was very nice for someone like me who doesn't come from these backgrounds. And also that you covered a lot of things that are like, oh, yeah, I guess that makes a lot of sense, but I never would have thought of that, which of course I don't have any experience in fieldwork myself either, but it's good to know in case it ever comes up. But one of the things that I really appreciated in it was kind of right up front. You talked about the differences between fieldwork and lab work and how they complement each other and why both of them are important. So I was hoping just to get us started, you would tell us more about how these two different kinds of science research help each other and are both necessary.
Sure. Well, fieldwork and lab work, they're not opposing approaches. They're not alternative approaches. They are two complementary approaches to dealing with the same issues or the same questions. And really, you could think about them as existing along a continuum or a sort of a hierarchy of complexity. And this was discussed in a really great paper by Reed in 2003, which described research as existing within a hierarchy of complexity. And in that paper, some studies were depicted as occurring within controlled environments, and such as the laboratory, and this allows very precise interrogation of mechanisms of behaviour independent of any confounding factors, and that approach allows a deep understanding of the underlying processes. However, it can be a little bit lacking in terms of relevance. In other words, we still don't know necessarily how those same factors play out at a field scale or in the natural environment. And on the other side of the continuum, we have fieldwork, which has huge relevance and direct applicability and allows understanding of processes and patterns as they happen in reality. But sometimes it can be difficult to delve into the underlying mechanisms because of the spatial and temporal variability. And this is why the two approaches can be coupled so effectively. So while one allows understanding of the underlying principles, the other demonstrates how they play out where it matters in the real world. So let's take an example, right? A project might have a laboratory study, such as an incubation, which could show nutrient availability at certain fertilizer rates on particular soil types. High precision, but relatively low relevance. But this could be accompanied by a plot trial over multiple years, which would demonstrate crop requirements at field scale, and this would allow development of recommendations for the farmer. You have greater variability, but also greater relevance. So they're not opposing approaches, they're really complementary.
I love that. I don't know why it tickles me so much, but I just really, I love that idea. And truth, I guess. It's not just an idea. But yeah, so once you kind of established that was why both are so important, we really started getting into some of the nitty-gritty here of like how to prepare for fieldwork, which I think might have been my favorite section. But there's a lot of questions, as I mentioned before, that I think people just don't consider or might not consider. So what are some of the things, if someone is going to launch into a fieldwork project, what are some of the key questions that they should be thinking about before they launch in?
Yeah, and I think what you say there, the word before, is the really important point. It's important to do your thinking and your planning ahead of time rather than kind of on the fly. And this will really prevent errors or just a greater struggle when it comes to the actual fieldwork. And the biggest question I think someone can ask themselves is why? Why am I doing this? What am I trying to achieve? So it's crucial really to understand what your hypothesis or question is, who or where it is relevant to, and what the ultimate goal of your research is. But that's kind of true for any aspect of research in the field or outside of it. So specific to fieldwork, you need to think about whether your own approach can yield appropriate, sufficient and timely data. And in the book, I break down each of these three categories. So when we talk about appropriate data, is the data that you will collect in your field experiment or your field study appropriate to testing your specific hypothesis or to providing contextual information? not all data is relevant, so it's also often very tempting to kind of throw everything in at the kitchen sink at a question and just take loads and loads of very different measurements to try and get a very comprehensive approach. But this can, in some cases, yield data that's not actually all that useful. So sit down and think about what data is actually relevant and choose judiciously. In terms of sufficient data, this means enough sites, enough blocks, enough plots, enough treatments, or enough time. And you need really to speak to a statistician before you begin your field research. Often people come to the statistician after they've collected all of this data, and the statistician usually tells them something like, you could have done with more reps, which is very disheartening to hear after the fact. So talk to your statistical team or statistical support before you design your experiment. And then finally, you need to ask yourself, am I going to get timely data out of this? And this has really two aspects. So number one, you need to have a balance between what is ambitious and what is achievable. And you have to remember that you are going to need time within your project to analyse the data. So the fieldwork aspect, whether that's a trial or whether that's a case study, it can't go on for the full duration of your research project. You need to probably have a few months at the very least for analysis of the data. So for example, if you have a 3-month project, maybe you need 6 months at the end of that to actually understand the data. So your field trial is not going to be able to extend into that final season. And it's very, very common for field experiments to overrun. And you don't want to be in that position. That puts huge pressure on you and on your team at the end of the project. You also need to consider, is there a time aspect to that is reflective of the process that you're trying to evaluate? So for example, if you're doing a crop trial, there's a seasonality aspect to consider, and you're going to have to design your experiment to fit around that. So there's some of the key questions I would ask myself during the design process.
Sure. And just for people who are new, which are the target audience for your book, where would one go to get a statistician? Is there just like someone at your institution usually? Do you have to go to an outside source? Where would you recommend people start for that?
Yeah, usually most universities or research institutes will have a statistician or a team of statisticians who are there to support the researchers, both the senior researchers and the undergraduate and early career researchers. So get in touch with your research support office, whether that's at your university or your employer, and they should be able to put you in touch with someone.
Hi everyone, I hope you're enjoying the show. Interested in learning more? Sarah's book, Fieldwork Ready, is now available for sale. Use discount code FWR35 for 35% off through the end of May 2021. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Thanks again also to our sponsors, Meter Group and Gasmet Technologies. Meter specializes in robust soil moisture sensing, innovative weather monitoring, cloud data logging, advanced data visualization software, and more. Their well-published scientific instrumentation is used worldwide in universities, research and testing labs, government agencies, agriculture, and industrial applications. Find world-class webinars about the science behind environmental measurements at metergroup.com/fieldlabearth. For Gasmet Technologies, conduct greenhouse gas flux measurements in the field using the GT5000 Terra. Weighing 20.7 pounds, splash-proof IP54 rated, internal pump and battery, and vibration resistant, the GT5000 Terra is a robust and portable multi-gas analyzer for fieldwork. Visit www.gasmet.com or email sales@gasmet.com for more information. Thank you for being our sponsor. Let's get back to the show. Great. Yeah, that's wonderful advice, and I'm sure they appreciate being contacted before rather than later as well. So, which leads me into kind of the next question here, which is, what are some of the key or maybe common mistakes that you see people making when preparing for or conducting field research?
Sure. So in the book, I divided up into kind of 4 categories of potential mistakes. So first of all, and these are the simplest mistakes, we have delays. Things simply take longer than you would often expect them to. And this could mean it takes you longer to set up your experiment due to purchasing equipment or acquiring sites. Or it could mean that you are delayed, your actual sampling procedure takes longer in the field than you might have hoped. Or it could simply be you got stuck in traffic on your way to the site. You know, there's all sorts of delays, and it's important when you're budgeting that we don't only budget our finances, but we also have to budget our time, and always leave some time for delays is what I would say. So that's the simplest mistake and probably one of the most common. We then have errors, and when I refer to errors, I'm specifically talking about mistakes or uncertainty that occurs within the data. Now, these can be systematic errors, and systematic errors mean that they are consistent and directional. So, for example, maybe you have, a pH probe that has point whatever of a margin of error, and it's always slightly high or slightly low. Well, once you know what that margin of error is, you can fix it via calibration and adjustment of the data. So systematic errors, they occur, but you can deal with them. We then have random errors in the data, and these are inconsistent both in their magnitude and in their duration. So you see this often as noise within the data. It's much more problematic than a systematic error. Sometimes it can be impossible to fix, but you should consider it when drawing your conclusions. And careful site selection and equipment maintenance can really help you avoid this. So it's a question more of avoidance than mitigation after the fact. And then we have what I think is probably the most common error in field research, and this is a transcription error. And this means that you have an error in the recording of the data or the labelling of the samples. I harp on about labelling samples a little bit to my students. It's so easily done, either because people sometimes don't have a very good labelling system set up in which the site, the replicate, the treatment is clearly marked, or maybe they write a little messily when they're in the field. We've all done that. Or maybe, water gets on the label and it runs. It's very easy to lose samples or lose quality data because of this. And really the best way to avoid that is to have a standard operating procedure for labelling that is clear and that's transparent. And also make sure you communicate with the rest of your team. Hopefully you'll have a team to work with either in the field or when you take your samples back to the laboratory. Because just because you understand your labelling doesn't mean your teammates do. So there's a communications aspect there. Other mistakes can be accidents. Accidents can happen to people, or they can happen to the experiment or the equipment. So that could be, livestock got onto your plot trial and they ran around all the plots. That's an accident. Or it could be that someone slipped and fell and they sprained their ankle. That's another sort of an accident. And the response to accidents really should be to stop and think, to ensure the safety of the people first and of the experiment second, to define what happened, so identify why did this accident occur and what exactly happened. Sometimes in the panic of something going wrong, whether that's a major or minor issue, we're so, rushed, or we feel rushed to make it right, that we don't actually stop and think, actually, what happened here? Why did it happen? Because that will allow you to define a much more effective and successful solution. And then you have to implement the solution. And the final mistake, although I don't know, it's not a mistake necessarily in the part of the researcher, but it certainly is something that can go wrong in the field, is vandalism, theft or interference. And this actually does happen surprisingly frequently, where people, sometimes out of curiosity or sometimes out of malicious intent, can interfere with field equipment, whether that's, going up and poking at your weather stations and what is this if it's not clearly labelled, or whether it's people sort of out of bad intentions damaging equipment or stealing equipment, which also happens, particularly with batteries, I would mention. Again, very disturbing and very frustrating. I suppose in this category you would also have animal interference with equipment or with sites. And again, you just have to try and find a solution, whether that's putting up appropriate signage to ward off people and to identify your property, or whether it's putting up protective fencing or netting or other protective equipment to keep livestock or wild animals away. You just kind of have to evaluate your site and deal with this and try and set up preventative measures so that these things don't occur. The most important thing, I suppose, when it comes to mistakes in fieldwork is don't get too upset or too panicked. Mistakes happen to absolutely everyone. I don't know a single researcher, myself included, who hasn't had some sort of a mistake or error occur in fieldwork that has them tearing their hair out or thinking, oh my goodness, how on earth am I going to deal with this? But the point is that everyone encounters these challenges and that you can deal with them, and don't let it derail your project too much. Just find a solution and kind of get on with it from there. And we have some advice, or I have some advice in Fieldwork Ready that should help you do that.
Yeah, I like that this book takes such like a gracious and calm approach to things, of just like, it's fine, like it will all be okay, just, you know, relax, think about it, you know, and move forward. I like that a lot. I'm also going to sneak in a bonus question here, because something that I liked that you mentioned a lot throughout both, you know, budgeting time and ways to prevent mistakes and prevent, you know, risks and hazards, which we'll talk about in a minute, was rest. Can you talk about that? Just like why that's such a key component, and how you can kind of prepare or set your plans aright for rest?
Yeah, absolutely. I think it's something that's overlooked quite a bit in field research. Field research is exciting. Like most people who do field research, they want to be out in the field, they want to have their boots on the ground, they want to be, you know, wading up a river or digging a soil pit or, you know, setting up camera traps. They're excited and they're enthusiastic people, and there's always the temptation to push for more data, one more rep, one more site, and to kind of cram a lot of things in. And that's really admirable, and I'm in no way trying to put people off that. I'm very much of that opinion and that, I suppose, demeanour myself. However, you have to acknowledge that we're all only human, and we all operate best when we are rested, when we are fed, and when we're appropriately dressed and prepared. And really, when you're overtired, you may or may not be aware, but you are mentally and physically less capable than you would be if you're correctly rested. I suppose this is most stark to me when you're doing a lot of driving to reach field sites. Driving is actually an exhausting and very demanding task, and that's why there's legislation in all different countries about the amount of rest time that you should have if you're driving long distances. And I think we, both for the safety of ourselves and for the quality of the data that we are collecting, it's important to allow time and have a strategy for rest. So whether that's saying, well, I'm going to take my 20-minute break at such and such a time and stick to that plan, or whether it's actually evaluating yourself and saying, do you know something, I'm actually too tired, or I feel that the standard of work is starting to slip. I'm going to call it a day now and come back tomorrow and finish the measurements. That might be the most judicious thing to do. We have signs by our highways here in Ireland that say tiredness kills, so that when people are driving, they'll see those signs and remember, actually, I've been driving a very long time now. I need to pull in. I need to have a coffee. I need to have a rest. And that is the absolute truth. And it's true in the workplace just as much as it's true in the roads. So that's something that I wanted people to be really, really aware of.
Yeah, I thought those were great reminders throughout, especially, you know, when dealing with equipment, you know, or vehicles that could potentially harm more than just yourself. Very important to keep in mind. Which kind of brings us then into our next section, which talks about risks and hazards, and you had a whole section in the book that was talking about how to assess these, the differences between them, different kinds. So can you tell us more about that?
Sure. Many of your listeners are probably a little bit familiar with doing risk assessment when it comes to laboratory procedures. And luckily for us, everything in the laboratory has SOPs and has clear labelling and all of that. So we're quite aware, we're quite conscious of the idea of risk in the lab setting. But sometimes people forget about that hazards and risk also occur outdoors in the field setting as well. So there's two elements to risk assessment. First of all, you have to identify the hazards. Now, what is a hazard? A hazard is anything that has the potential to cause harm or injury. So potential hazards in fieldwork could be they could be the equipment that you're using, such as a shears, such as a mallet, such as, a mechanized auger. It could be the wildlife that you're around, such as snakes, such as ticks, things like that. Or it could be simply the environment itself, such as the riverbank, which is slippy, there's water, there's the risk of immersion. They're your hazards. We then have risk. Now, what is risk? It's sometimes a little poorly defined, but it is the likelihood and the magnitude of injury or harm that could occur. So, risk is a combination of the likelihood of harm, the magnitude or severity of harm, and the people who might be affected. Because, of course, some people, depending on their physical characteristics, because of their age, because of any underlying conditions, may be more or less greatly affected by a hazard if it should impact upon them. So the important thing in risk assessment is to first define the hazards and then figure out how risky each of those hazards as an individual are. Now, there's two approaches to defining risk. Some risk assessment procedures use a numeric scale, so 1 to 5. I don't prefer a numeric scale myself because it's poorly defined. I mean, is 1 high or is 1 the lowest and 5 is the highest or 10 is the highest, depending on how big great your scale is, or what is the difference between a level 5 risk and a level 6 risk. It's hard to define. Perhaps a better or a more clear approach is to have a grade of risk, so a low, moderate or high risk, or even a traffic light system, which is particularly useful if you're dealing with numerous team members who may or may not have the same language. That often happens if you're doing international research, whereas everyone can understand quite readily a red, amber and green system. That's kind of fairly universally understood. In terms of risk and hazards, the next thing to do is to figure out how you're going to deal with it. The first step is always to minimize exposure. So if there's a hazard and you can avoid that hazard entirely, that's the best possible solution. And the best analogy I can think of is a ladder. What's the best way to avoid falling off a ladder? You don't go up the ladder. So the first thing is to minimize your exposure. Sometimes that's not entirely possible. For example, if you're a water quality researcher, a freshwater researcher, and you're researching the Great Lakes, well, you're probably going to have to go near the Great Lakes. Removing the water aspect isn't necessarily possible. However, you can make the hazard safer. So that's minimizing your time there, or accessing the lake or the river, wherever it might be, through a safe access point, things like that. Next up is to use personal protective equipment, so PPE. Exactly the same as you do in your laboratory. You're conscious to wear your white coat, to wear your gloves, to wear your mask, to wear your goggles, or whatever other equipment might be required depending on the technique or the materials that you're using. The same thing in environmental research outdoors. You need appropriate footwear, appropriate clothing. You might need safety jackets or harnesses, things like that. You might need helmets. You will probably need gloves of some description. The PPE that you use will depend entirely on your task and on your environment. We go into quite some detail in the book, particularly about clothing. Really, most of the clothing you will wear is having some sort of a protective role. So give some thought to that and some investment. Invest in good PPE. And remember also that the PPE has to be appropriate for the person in question. In other words, it has to fit you and fit you comfortably so that you can work effectively while using it. you need to use your equipment correctly. And this might require some training ahead of time. So, for example, if you're using an auger or a drill or something like that, or something that, say a shears, something that has sharp edges, you need to be prepared in advance and know how to use that equipment and to use it safely. Beyond that, you have a responsibility as the individual in the field to stick to that training. So if you received training and you choose not to follow those instructions when you're actually out in the field, well, I hate to say it, but you're the one who is responsible. So you have to be disciplined just as you would in the laboratory. And finally, even when you take all precautions, there are unknowns and unexpected things that happen. They happen to all of us, both in our research lives and in our own lives, and you have to have emergency plans in place. So that means, who do you ring? Who knows that you're out there doing research? Who are the emergency services in the local area? What do you do when something goes wrong? And having a plan ahead of time will allow an appropriate response to be put in place as soon as possible. And remember, when it comes to emergency, or when it comes to physical injury in particular, time is often of the essence. And I think this brings to mind another issue in fieldwork, is the lone working issue. It's very common, even if you're working in a team in fieldwork research, to be spread out or to be out of line of sight of one another. So you have to have a plan for communication and for checking in, or for responding if someone fails to check in. Because, you know, if someone has been slipped and fallen, or if they've been, you know, accosted by an animal, for the example, someone needs to be able to respond to that, and to respond to that in a timely fashion. So you need to think about these things ahead of time. It's really, things mostly go wrong when there's a failure to respond appropriately, and that can be due to a lack of planning.
Yeah, I really liked this section because it really is, you know, just taking a little bit of time before can save you just a world of trouble. And you are so thorough in the book of just like, here's all of these different types of risks that you might not be considering. Here's some anecdotes of things that, you know, a little bit of prep work saved me time, and, you know, prevented potential injury or risk there. And also you're very thorough in like communication styles, options. You know, you mentioned the buddy system and go through like several iterations of what that could look like. So highly recommend anyone to go read the full book and really do your due diligence to stay safe out there. And thank you, Sara, for being so diligent and thorough in really just laying out all of these things that, like I said, and you said to me earlier, are, you know, can be very common sense things, but it really just takes the time to actually sit down and think about it to really save people a lot of potential trouble. But we do not have time to go through your entire book, and of course want people to go read it for themselves and enjoy what a lovely book it is. So we will kind of wind down at this point. I've got 3 questions left for you. First of which is, if people want to learn more about fieldwork, any of the things that we've talked about on this show, anything like that, where can they go?
So the best place to find out about Fieldwork Ready is to go to the Wiley website. That's Wiley. They're our publisher, and just search for Fieldwork Ready and you will be able to purchase it there. It's either in hard copy or in ebook format. You can also follow me on Twitter at Sara Vero 89 and hashtag Fieldwork Ready. And I love to talk about fieldwork. I see some great fieldwork stories there, and it's so exciting to see everybody's photos and the exciting research everyone is doing. And I would say, on the subject of fieldwork and communications, there's a great network of fieldwork researchers out there, and who I even tap into for help and for advice, and you can too. So if you see someone who's using equipment that you're interested in, or who's investigating a similar topic, reach out to them. People who do fieldwork are all too keen to talk about it and share their experiences and advice. So don't feel you're out there alone, even if you're the only one in your research centre doing a particular type of work. There's plenty of help out there if you look for it.
Great. Yeah, that's great advice. And I highly recommend following Sara on Twitter. We do. And it's always so fun to see like your photos and how passionate and excited you are for the field work that you do. So that's always lovely. Second question is, if people are looking to get involved in field work or field work related issues, how can they do that?
Yeah, I suppose if you're an undergrad, reach out to your lecturers or to the postdocs and early career researchers in your research centre or in your university, because many of those will be doing field work, and there may be opportunities for you either to go and visit, to see field days, or to become involved. Really, it's a question of asking the people around you. There's lots going on. It's a question of throwing yourself into it. And beyond that, I would say, if you're a early career researcher, or if you're a PhD or a master's student, don't feel intimidated about running a field trial or any other sort of a field experiment. You're more than able to do it. The question is to design an effective project and a sensible project, and then look for support within your university. Most universities are very supportive of field research, because even as we move more and more to incorporating models in agricultural and environmental science, we still appreciate and understand that they need to be grounded in practical reality.
Yeah, that is more great advice, of course. Reaching out to people is always great. And then final question for you is, what is one fun fact that people would not know about you if all they had was your research?
Okay, that's an interesting one. So most people know that Ireland is very famous for our horse racing industry. We have great race horses and great race tracks. And before I got into research, I very nearly had a different career. When I was 15, I went to the jockey training school in the Curragh, and I spent a year riding racehorses and learning everything there is to know about being an apprentice jockey. I didn't go on to do an apprenticeship at the end, and we decided after the year that it was better for me to go back to school and on to university thereafter. But yeah, I could have had a very different path in life altogether. Still outdoors, but rather different.
Oh my goodness. Yeah, what? That is a very fun fact. Do you like see horses in your fieldwork and are just like think about like what could have been, or glad to still see them?
I had a water sampling site a couple of years ago, and there was a training gallops nearby, like within eyesight of my water sampling point, and sometimes I'd look across and be like, it could have been so different. But I'm not sorry. I enjoy what I'm doing now very much.
Well, wonderful. We are so happy to have you out in the field, both literally and metaphorically, I guess. And thank you so much for writing a wonderful book. We encourage anyone who is interested to go get a copy for themselves. And yeah, thank you so much for being on the show.
Thanks, Abby, and thanks for your wonderful podcast. It's kept me company on many, many field trips.
Oh, we're happy to hear that. Thank you. Thank you for listening to Field Lab Earth. You'll find links to today's resources in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe, and don't forget to rate and review us on Apple Podcasts, Podchaser, Stitcher, or anywhere else you find your podcasts if you like our show. This podcast is a joint production of the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by guests are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.